I just wanted to go through a few examples of everything that we're going to be doing on Zoom with you, because I don't want to take the risk of, recording something and then there's some technical difficulty. So all of these are examples that will be on the Zoom lessons. If you need a refresher, you can go back to this, or if you missed a lesson, you can go back to this, and always feel free to email me if you have any questions. So for the first lesson, we're just going to start at looking at the different ratios. So we have, this is abbreviated SIN, but it's really called sine. This is abbreviated COS, but it's really cosine. And this is abbreviated tan, but it's really tangent. So those are the three trigonometry ratios that you'll need to know. And you probably learned from the other video, or if you're in period 2, we did a whole lesson on it. SOHCAHTOA is what you need to remember. And if you remember SOHCAHTOA, then this whole unit will be super easy. What that stands for is that the sine is always equal to the opposite side, I'm just abbreviating, over the hypotenuse, SOH. Cosine is always equal to the adjacent side over the hypotenuse. And tangent, that's CAH for cosine, ka, and tangent, TOA, is O over A, so that would be the opposite over the adjacent. So the way that you can tell those from the picture is to first label your hypotenuse. So you find your 90-degree angle, and whatever's directly across from it, so you can kind of draw a line coming right out of it, that's automatically hypotenuse, so that's H. And we're looking at angle P for all of these problems. So the next one I always find is the opposite, because you just take the angle that you're looking at, P, and draw a line directly out from it. Whatever side you hit, that's the opposite. So that's O. And then the other side that's left over is A for adjacent. So if we want the sine of angle P, it would be opposite over hypotenuse, O over H. That's 10 over 26. Now, if you can simplify the fraction, go one more step. So you can divide both of those by 2, giving you 5 over 13 for the sine of angle P. For cosine of angle P, you're taking adjacent over hypotenuse. So this would be 24 over 26. Again, you can simplify by dividing by 2 in this case. So that would be 12 over 13. For the cosine, and then to find the tangent, you're taking opposite over adjacent, so that would be 10 over 24, which once again you can divide both by 2, leaving you with 5 over 12. We'll do another example. Now we're looking at angle B, so let's circle our angle. Start by labeling your hypotenuse, so find 90 degrees, right across from it, that's H. And then label your opposite. So the angle that you circled, right across from it, that's opposite O. The other side that's left over is adjacent. So for sine of angle B, we need opposite over hypotenuse. So that would be 14 over 50. Again, we have to simplify, divide by 2, 7 over 25. Cosine, adjacent over hypotenuse, 48 over 50. Again, divide by 2, 24 over 25. And then last one, tangent is opposite over adjacent. So that's 14 over 48, which gives you 7 over 24. So that's all we're doing for the first lesson. If you have any questions, just email me, and you can pause now. Okay, so next we're going to be looking at finding side lengths. So to find side lengths, you'll need to know at least one angle and one side. So we'll do a few examples together. So first one, we know this angle here, 25. Always start by labeling your triangle. Hypotenuse, opposite, and then adjacent. So hypotenuse is right from the 90, that's H. Opposite is right across from the one you're given, and then adjacent is the one that's left over. So we can actually solve for B and C here. So let's solve for B first. If we're looking at B, we know that that's our opposite, and then we know that this angle A, or side A, sorry, the adjacent side, is 8 meters. So we're going to use that to find the other sides. So we have O and A when we're solving for B. So we're using OA would be TOA, telling you to use tangent. So you're going to write tangent of the angle 25 is equal to opposite, which is B, over adjacent, which is 8. And then to solve this, to undo dividing by 8, you just multiply by 8. So times 8 on both sides. That will cancel it out here. And you're left with B is equal to 8 tangent 25. Now, tangent 25, you can't really figure that out unless you have a calculator. So you can use the scientific calculator, graphing calculator, or if you don't have one of those, I'm going to show you a little website that you can use. So just remember, it's 8 tan 25 that we're putting in. Okay, so if you go online, you can go to desmos.com/scientific, and that will bring you to the scientific calculator that you can use online. Now you do have to make sure that it's set in degree mode. Everything is Russian on a computer that I have access to, but I will show you where it is. It will still be in the same place. So see over here, there's like a little box, you can click on it. That, if it's like this, that's telling you it's in radians, and you're gonna get really weird answers. So make sure that you click over here to like move that little slider. And this tells you that it's in degrees. It's just Russian, but on yours it should say maybe DEG, or actually the word degree, but make sure it's in degrees. And if you're getting weird answers, then like negatives or really, really small numbers, then just double check that it's set to the right mode. Okay. So we need 8 tangent 25, and that should give you your answer. So the final answer would be, you can go 2 decimal places for me, that's fine, 3.73. So B is 3.73, and our unit is meters. And then to find C, I'm going to run out of room over here, so I'm just moving up here. So to find C, now we have H and A. So H and A, AH is CA. So that means you're using cosine of the angle of 25 equals A over H. So that would be 8 over C, which we don't know. So you can figure this out the same way. Start by multiplying by C to cancel it out. But then you still need to get C by itself. So now we have C times cosine of 25. So what you have to do now is divide by cosine 25 to get C alone. So C is equal to 8 over cosine 25. And again, all of this is in the original video that hopefully you watched. I assigned it like March 12th. So there's more details, and I probably go a little slower in that video. But of course, just ask me if you have questions to reach out. Okay, and again, I'm just going to plug this in the calculator, 8 divided by cosine 25. Now we have 8 divided by, you can even just type it in on the keyboard, cosine 25. So our final answer for the hypotenuse is 8.83. And we are in meters, so C is 8.83 meters. Most of the problems that I'll give you, I'll just ask you to find one missing side. Okay, so let's start by labeling what we have here. So 90 degrees across from it is H, hypotenuse. 60 degrees is their angle that we're given. Across from it is opposite. Now, since we don't have to find this other side, don't even bother labeling it. So you have O and H, which is so or sine. So sine of 60 equals opposite, which is x over 30. So this one's nice and easy. To undo over 30, you're going to just multiply by 30. And then just plug it into your calculator. 30 times sine of 60. Go back over here, 30. Oh no, you need to clear it out first. Or you can hit enter and go to the next line. That would also work. So 30 times, you don't even need to really put the time sign, because whenever there's no operation, it's automatically multiplication. So it's 25.98. And here we have feet. And that's all you really need to do. Okay, next one, again, start from 90. Across from it is H. Circle the angle you're given. Across from it is in the O. So we don't need A again here. So we have OH, you can write it out first, that's so. So you have sine of 46 equals 8 over x. So now x is in the bottom, so again we have to move it to the other side and then divide. So we always undo division with multiplication. So first you're multiplying, but in this case multiplying by x, which just gives you one extra step. So then you have x times sine 46 equals 8. So to get x by itself, you have to do 8 divided by sine of 46. So you can click this button here too, we'll just bring you to the next line on the calculator. So 8 divided by sine 46, and then click enter on your keyboard. 11.12. So our hypotenuse is 11.12. There's no unit here, so just 11.12. Okay, and I'm not going to keep going back to the calculator every time. I will do it again when we have to do the inverse functions, but for right now we're okay. Alright, so start by labeling your hypotenuse from the 90. Across from it would be h, but see how there's nothing there? You don't even want to use h in this problem, so don't confuse yourself, you don't have to write it. Circle your angle. Right across from it is O, and then the other side is A. So now we have O and A, meaning we're using TOA, which stands for tangent. So tangent of 46 equals 7 over x. So again, we always have to get rid of what's over here in the bottom by undoing division with multiplication. So times x, and then to get x by itself, we have to divide by tangent of 46. And I'm just going to go and put in the calculator. This sign means approximately. I should have really put that for all of them, but it's okay. I'm not going to take off points for something like that. So 7 divided by tangent of 46 is 6.76. Again, there's no unit here, so you don't have to worry about writing it, or you could just write the word units. Alright, and that's it for this set of lessons. Okay, so next we're moving on to some word problems. In the Zoom lessons, I probably had the full word problem up, but I don't have access to a printer, so I'm just like writing down the important pieces of the problem. From there, we'll always start by drawing a picture, label our picture, and then we can solve. So the first problem was somebody wanted to build a ramp to the top of their stairs, like on their deck. So they had a 2.8 foot high deck. They want the angle to be 8 degrees between the ground and the deck, and then we want to figure out how long should the ramp be. So let's draw a picture first. So it doesn't matter which way you're going, as long as it's not like upside down. So our deck could be over here, and it's 2.8 feet high. The ramp is this one on the diagonal, right? We don't know it, but x. And they want this super, super small 8 degrees. So now we have a picture just like in the last few problems. So we're just going to first label from the 90 is H. From the angle we're given is O. So we're using OH. Again, we're using SO, which stands for sine. So we have sine of 8 degrees equals 2.8 over x. So again, always multiply by whatever's in the bottom there, times x, and then to get x by itself, we have to divide by sine of 8. And I'm just doing it on the calculator. 2.8 divided by sine of 8 gives you 20.12 feet. That's how long the ramp would have to be. Our next one, somebody was standing, I think it's Weston, was standing 45 feet from the base of a tree. So you can start drawing it already. You're always assuming everything is like perpendicular to the ground. The tree is straight up. I know my drawing's not perfect. So here's Weston. We just put a W there. He's 45 feet. Base always means bottom. Here's your tree. The angle from the ground to the tree is 63 degrees. There is actually a little tool that you can use. I forget what it's called, but you can measure the angle of your line of sight from something. And we want to figure out how tall is the tree. So always start with your 90. Across from it would be hypotenuse, but we don't know anything about this. We don't need it in the problem. Don't label it. Then circle your angle. Across from that is your opposite. Left over is adjacent. So here we have O and A. So we're using TOA, which stands for tangent equals opposite over adjacent. Oops, but I forgot to put the angle. Oops. Tangent 63 equals x over 45. And again, we're always starting by multiplying by whatever is in the denominator on this side. So times 45 times 45. X is isolated by itself now, so you're just plugging this in your calculator. 45 times tangent of 36 gives you 32.69 feet for the height of the tree. Okay, next one is about building a handicap ramp. There actually is a regulation on handicap ramps that the angle between the ramp and the ground must be 4.8 degrees, so that way it's like a low enough angle and it's not too hard to get up. So 4.8 degrees here. Ground is always at the bottom, right? We're placing this ramp starting 22 feet away from the base of the building. Base tells you bottom. And we want to know how long is the ramp. The ramp wouldn't be here, right? The ramp is always going on a diagonal. Okay, so start again. 90 across from it is H. 4.8 across from it would be opposite, but we don't have it, we don't need it, don't label it. Leftover is adjacent. So here we have AH, which stands for CA, which tells us to use cosine of 4.8 degrees equals A over H. So that would be 22 over X. So again, times X, always multiplying by whatever's in the bottom. We have one more step. We have to undo this multiplication by division. So you're going to do 22 divided by cosine 4.8. And that is 22.08 feet long. So it's only, it's not too much longer than the base. Alright, now we have a pretty cool one, like crime scene investigators actually can use trigonometry. So say that, something was launched out of a window on 47th Street. Now, this is there to throw you off. Cross it off, who cares what number street it was, right? The angle of impact with the ground is this amount, 57. So let's kind of sketch it out. Let's assume this is the building. This is the ground, of course. The angle of impact with the ground would be this angle here. So that is 57.8539 degrees. And there actually are tools that you can measure the angle of impact with the ground. So this is like realistic. And it landed 87.5273 feet away from the building. So the distance from the building and the object is 87.5273 feet. And then say they wanted to figure out, which window was it launched from, which floor. If they knew how tall each floor was, and if they could find the height that it was launched from, they could figure out, who threw it out the window or whatever. So here's the building, and we want to know this height. I'm going to call it H for height. Doesn't matter what you call it. And again, assume the building is like perfectly perpendicular to the ground for all of these. So start from your 90. Across from it would be hypotenuse, but we don't need it, we don't know it, don't label it. Actually, I probably shouldn't call this H because it seems like hypotenuse. Let's call it X. Okay, our angle that we have across from it, that's O. The other side is A. And I knew this was going to happen. I have to answer the door real quick, so just 1 second. Okay, sorry about that. Hopefully it doesn't happen again. Alright, so here we have opposite and adjacent. We don't know anything about the hypotenuse, we don't need it. So OA is TOA. So that tells you use tangent of the angle 57.8539 equals opposite over adjacent. So X over this 87, what was it? 87.5273. Again, you're multiplying by the denominator over here. Cross it off. And then here I'm just running out of room, but it's times 87.5273. You can put it into your calculator. We should get a big number for this one because it's being launched from a building, and usually buildings are pretty high, right? So 87.5273 times tangent of 57.8539. Yep, so we have 139.28 feet. Now, you could take this a step farther, and if you want, when you're doing your project or you have to make your own problems, if you add an extra step, you get extra credit. So they might say like every floor in the building is like 20 feet high. I'm just making up a number, and then which floor did it come from? So you'd have to basically divide this by 20 and figure out it would be about the 7th floor, 6th or 7th floor for this one. But that's just, you know, optional, extra if you want to add something to your project. And I think that's all the word problems for today. So you can pause here. And next we're moving to finding angle measures. Alright, so same exact process, except we're going to be using the inverse functions. I wish I could show you how to do that on a regular calculator, but oh, you know what? I wrote the steps actually. So on a regular calculator, if you want sine inverse, this -1 means inverse. You're going to click on your calculator second and then sine. Same thing for cosine inverse and tangent inverse. You would click second cosine, that would give you the inverse function, and tangent inverse, you would click second and then tangent. I'm going to have to try to figure out how to do it on this computer with everything in Russian, but we'll work through it. Okay, so first problem, first example. Always start the same way. Start from your 90, opposite it is hypotenuse. Circle your angle, opposite it, that's 15, but it's opposite. We don't need the adjacent in this problem, so write out your OH, which tells you to use SO, which is sine. So you're going to have sine of the angle, so X is in there, equals 15 over 24. So now when X is in the parentheses with the trigonometry function, to undo this, what you're going to do is take the sine inverse of the fraction. So to solve for X, you're going to write sine inverse of 15 over 24. Again, you can do that on your calculator by clicking second sine 15 over 24, close your parentheses, that's your answer. I think these are actually easier than finding the side lengths. Not easier, but like it's like one less step. So let's try to figure out how to do it on this scientific calculator. So again, it's decimals.com / where is it? decimals.com / scientific. And then this option here only gives me sine, cosine, tangent, so I'm gonna just play around with these and see if one of them is the inverse functions. That's letters. Ah, there we go. Okay, so this third one here, whatever it says on your computer, is sine inverse. I could try to say that in Russian. I don't know. It would be funkcja. Ah, funkcja stands for functions. Makes sense. Okay. That's nice to know. A little, learned something else too. All right, so we need sine inverse, but on yours, whatever it is, the third one, it probably says word functions. Sine inverse of 15 over 24. And I'm just going to use the calculator to type it. 15 over 24. So, and again, make sure you're in the degree mode. This stands for degrees here. If you were in this mode, you would have radians, and see how you get a weird number like 0.675. The angle's not going to be that small, so make sure you stay in degree mode. So the angle would be about 38.68 degrees in this problem. 38.68. Don't forget degrees for your angles. All these answers should have degrees, not feet or something. It's not a side length, it's an angle measure. Okay, we'll do a bunch more together. I actually have 6 planned for Zoom, so I might as well just do all 6 of them. Alright, so start with 90. Across from it, hypotenuse. Start with x. Across from it, that would be opposite, but we don't have it, we don't need it, so this is a. So now we have AH, which is ca, which stands for cosine of x equals 8 over 11, adjacent over hypotenuse. So then to find x, you're taking cosine inverse of 8 over 11. Let's go back here. So cosine inverse. Oh no, don't put it in the same line. Sorry. Hit that enter button that blew this one. Cosine inverse of 8 over 11 is 43.34 degrees. Alright, so we're always starting the same way. From 90 across from it would be hypotenuse, but we don't need that side, so don't label it, don't confuse yourself. Circle your angle. Across from that is opposite, and this is adjacent. So we have OA, which is TOA, so we're using tangent of the angle equals opposite over adjacent, 20 over 37. So now we're not taking sine inverse or cosine inverse, we need to take tangent inverse of this fraction, 20 over 37. So now we've finally used all 3 of them, so hit that enter button, and then tangent inverse of 20 over 37, which is 28.39 degrees. Okay, for the next 3, I'm not going to keep going back to the calculator, but again, if you need help with that calculator, just email me. Okay, so across from 90 is h. Across from x is o, but we don't need it. Left over is a. So now we're using ah, cosine. So cosine of x equals a over h, 18 over 23. So x will be the cosine inverse of 18 over 23. And I'm just going to put it on the calculator. 38.499999, so we're going to round that to 38.5 degrees. And we'll do 2 more. So across from 90, h. Across from x, o. We don't need this other side. Once you have 2, that's enough. So is sine. So we're going to have sine of x equals o over h, 40 over 41. When you're solving for the angle, you're just taking the inverse of the ratio. And again, just putting it on the calculator. 77.32 degrees. One more. So again, across from 90 would be H. We don't need it. Across from the angle you need is O. Left over is A. So we have OA, which is TOA again, just like the one above it. So tangent of x equals opposite over adjacent, 7 over 5. So when you're solving for the angle, you're taking the inverse function of the ratio. And just put that on your calculator. Tan inverse 7 over 5, 54.46 degrees. So that's all for this type of problem. And again, if you have questions or something, just email me. I'm happy to help you. And finally, we're moving into some word problems using the inverse functions to find missing angle measures. Again, I don't have access to a printer for a while, so I just wrote down the main points in the problems that I'll be doing on the Zoom lessons. So this one was somebody wanted to make a ramp to the top of their deck stairs. The deck is 4.5 feet high. The ramp is 26 feet long. And they want the angle formed by the ramp and the ground. Now, they also have a requirement that this angle must be 10 degrees or less, so we'll have to answer one more question. Is it 10 or less or no? So let's draw our picture first. So the deck is 4.5 feet high, that's here. And the ramp is 26 feet long. And we need this angle. And again, doing this the same way as the ones before it. So start from 90, across from it is H. This angle that we need to find, across from it is O. You don't need the other side. So OH is so, which stands for sine. So sine of the angle that we don't know. You also might see this symbol, theta, stands for angle. So I'm just going to write it like that in case you see it like that. And then it's opposite 4.5 over hypotenuse 26. And then to solve for the angle, you're taking the sine inverse of 4.5 over 26. And let's see, I'm just doing it on the calculator. Should be 9.97 degrees. And does it meet the requirement of 10 degrees or less? Very close, but yes, it does. Okay. Our next one, there's a 50-foot ladder used to reach a window that's 30 feet high. So let's sketch out the picture. The ladder is, of course, on the diagonal. The window is 30 feet high in the building. That's straight from the ground. We want the measure of the angle between the ladder and the ground, which would be here. This is your ground, right? All right, start from 90. Across from it is H. Angle that you need. Across from that is O. So again, we're using so, which is sine. So sine of the angle equals O over H, 30 over 50. So the angle will be, since we're solving for it, we have to take the inverse function of the ratio. And you can just do that on your calculator. It gives you 36.87 degrees, approximately. Alright, and again we have one with handicap ramps. So now we know the length of the ramp is 37 feet. And it's being placed 18 feet away from the base or bottom of the building. And we want the angle between the ladder and the ground. And then we have to see, does it meet the requirement by law of 4.8 degrees or less? If not, they can't build this ramp. So let's see, from 90, across from that is H. from theta, the angle that we need across from that, would be O, but we don't need the height of the building in this problem, so just skip it. And then we need x. Really, all you need to solve all these problems are just two sides. So now we have AH, ka, which stands for cosine. So cosine of the angle equals A 18 over H 37. Solving for the angle, so you're taking the inverse function of the ratio. So that would be cosine inverse of 18 over 37 is 60.89 degrees. So I don't know, does that meet the requirement? This cannot be a handicap ramp. Imagine having a 60-degree angle to go up in a wheelchair. No way. This is not possible. Okay, and then finally, last one. So a 54-foot long piece of wood is being placed 20 feet away from the base of the building. So assume this is the building with the ground. The base is going to be 20 feet away, this distance, and then the wood itself is 54 feet long. And we want the angle made by the wood in the ground. So it would be here, wood, ground. So from 90, that's your H hypotenuse. From the angle you need would be O, but we don't need it in this problem. And we have the adjacent. So again, we have ka, which stands for cosine, and cosine of the angle equals adjacent over hypotenuse, 20 over 54. And again, you are finding the inverse function. Oops, I wrote it the wrong way. Alright, we're finding the inverse function of the ratio, and that will give us theta, the angle. So theta equals this. So cosine inverse of, was it 20 over 54? Yeah. 20 over 54, 68.26 degrees. So that's all the lessons for this unit. And then I hope you have fun making your own problems, and I can't wait to be back to normal life again. So, of course, if you have questions, just send me an email, reach out. I'm here to help, and have a wonderful day.